Systems 3209, Unit 3, Earth's Materials. References can be found in the chapter text in chapters 2, 3, 6, 7, and also in the curriculum guide in Appendix A and Appendix B. Unit 3, Topic 4.7. In this topic, we will look at the stages of coal formation. We will focus on explaining the processes associated with the 4 stages responsible for the formation of coal. During the formation of coal is a sedimentary rock. It also can be a metamorphic rock, depending upon the stage. So coal, which is a sedimentary or metamorphic rock, is produced in swamps where there is large-scale accumulation of organic matter from plants. This organic material consists of carbon, oxygen, and hydrogen. When plant material is buried, the hydrogen and oxygen in compound form can form H2O, is released, leaving behind the carbon. 2 major coal-producing periods are known in geologic history. During the Carboniferous and the Permian periods, the continents were approximately located near the equator and covered by shallow seas. The type of environment favored the growth of vegetation, and rapid burial led to the production of coal. Text references can be seen on page 170 and 172. Coal is considered a fossil fuel, and fossil fuels are non-renewable fuels that formed long ago from the remains of once plants or animals. We will study 2 types of fossil fuels in this course. Fossil fuels that result from the formation of plant material, which we call coal, and also from animal material that migrated through rock and is stored, which we call petroleum. That will be studied in Unit 5. The origin of fossil fuels starts with photosynthesis. And photosynthesis is a process where sun's energy is taken in by plants, and this energy is stored within the plants. Note that the reaction runs in reverse. It produces energy that was stored in the plants and releases carbon dioxide and water. Let's look at the formation of coal. The formation of coal involves many different stages. The first stage is the formation of peat. Swamps are areas where organic matter from plants accumulate. As the plants die and get buried, they compact to become peat. With time and more compaction, almost all of the water is lost, and 3 different grades of coal will result. We should note at this point that peat is not a rock. It is just the first stage in the formation of coal. So I repeat, peat is not a rock, but it's just a stage in the formation of coal. In the second stage of coal formation, we form a soft-grade coal. This coal is called lignite coal. With the compaction of peat due to burial, this will drive off the volatile components like water and methane, eventually producing a black-colored organic-rich coal called lignite. Lignite coal is a soft brown coal which consists of approximately 40% carbon, and the larger amount, 60%, will be volatiles, gas components like water and methane. Because it has more volatiles, lignite does not burn efficiently. So if we look at the diagrams to the right, we can see that peat, which is once decayed vegetative matter, gets buried by sediment layers. As the sediment layers buries the peat deep within earth, the weight of the layers above it will compress the peat and volatiles will be lost. So gaseous components and water components will actually migrate out of the dead organic matter, and what we will be left with is a thinner seam of coal. And this soft coal is called lignite coal, and it only contains approximately 40% pure carbon. This lignite coal will then go through further stages of burial where more volatiles will be released. The next stage of coal is the formation of bituminous coal. Further compaction and heating results in more carbon-rich coal called bituminous. This bituminous coal is a soft coal which consists of approximately 85% carbon, and there are lesser volatiles, only approximately 15%. This grade of coal burns easily, but it also produces a lot of smoke. So if we look at the diagram, going from lignite coal, we've provided with further burial by more sediment layers laid up on top. This will compact the lignite coal layer to even experience more pressure, and as it gets buried deeper into the earth, it's put under more heat. It will then migrate where a lot of the gas components, the volatiles, such as water vapor and methane and other gases, will be lost, which leaves a richer and higher percentage of carbon. So bituminous coal will contain up to 85% pure carbon. When we migrate into the fourth formation of the anthracite coal, during this formation, the layers of bituminous coal gets compacted even more, and during this stage it is exposed to compressional forces. So stage 4 shows the formation of anthracite coal. It says if the rock becomes metamorphosed, a high-grade coal called anthracite coal can be produced. This grade of coal forms a hard dark coal which consists of approximately 90 to 95% pure carbon, and when burned, it burns very hot and clean. This forms as a result of metamorphic conditions. Hence, anthracite would be considered a metamorphic rock. Because it has less volatiles, that is water and methane, anthracite coal burns very clean and produces a high amount of energy. So if we look to the diagrams to the right, we notice that we have our bituminous layer of coal, which basically is exposed to metamorphic conditions that would be higher heat and more pressure, generally by compressional forces as indicated by the blue arrows. These compressional forces, along with deeper burial and higher heat, will cause the sedimentary rock, bituminous coal, to change and metamorphose into a very high-grade anthracite coal, which contains up to 90 to 95% pure carbon, and it can burn very efficiently and very clean. So this is your highest grade coal, and it's a metamorphic rock. So when we look at the formation of coal, coal forms as it gets buried and compacted, and it's the result of plant material being buried and compacted. Different kinds of coal depends upon the formation process. This slide shows the different stages of coal. Here we have peat, which is dead organic matter, and we see the diagram of what peat would look like. It's almost like a spongy plant-like material. When we bury this material, peat, it starts to compact, and a lot of the volatiles are lost. Here we have approximately 40% carbon left, and this stage of coal is called lignite coal. Upon further compaction, the lignite coal will lose a lot more of its volatiles until it gets down to approximately 80 to 85% pure carbon. And this type of coal is called bituminous coal. And finally, in the fourth stage of the formation of the highest grade coal, we see the bituminous coal undergoing a lot more compaction and being exposed to metamorphic conditions where you see a lot of pressure coming from compressional forces and the heat, where it's buried so deep inside the earth that it forms a metamorphic rock called anthracite coal. A good way to remember the stages in the formation of coal is to remember the letters of the first letters in each of the stages. For example, we can remember the letters in order: P, L, B, and A. P would stand for peat, L would stand for lignite, B, bituminous, and A, anthracite. So all we need to do is memorize the 4 letters P, L, B, A. And that will give you a hint on how the different stages in the formation of coal are organized. Let's look at some example questions. Question 1. Which forms by metamorphism? So if we look at the different sedimentary rocks below, we see sandstone, which is sedimentary rock made up of sand, shale, which is a sedimentary rock made up of clay, and then we have bituminous coal and anthracite coal. And we know that the anthracite coal is the highest grade of coal which has been exposed to metamorphic conditions. So the answer to the first question, which forms by metamorphism, the answer will be A, anthracite coal. The second question reads, in which locality would coal deposits most likely form? So if we look at the environment for coal deposits, A says continental shelf, B, ocean floor, B says delta, C is the ocean floor, and D, swamps. Seeing that coal is made from once living material, swamps is an environment where once living plant material once existed, and once buried, it will form into coal if conditions are favorable. So the answer to the second question here will be swamps. Your turn. Take the time to complete the following question and prepare your answer, and the answer to the question will be on the following slide. You can pause your recording now to prepare your answer. Question reads, what is the correct sequence in the formation of coal? If you remember the sequence of letters that we discussed, the letters for sequencing stages of coal will be P, L, B, A. P standing for peat, so C or D could be appropriate answers. L standing for lignite, so therefore our answer must be D. P, L, B, A. So peat, lignite, bituminous, anthracite will be the answer to the correct sequencing of the different stages of coal. So your answer in this case would be D. Let's look at another sample problem. The problem reads, use a diagram to explain the 4 stages involved in the formation of anthracite coal. So we're looking at the formation of anthracite coal, and we know that anthracite coal forms when conditions are favorable for metamorphism to occur. We must start out with the first stage of coal, and that will be peat. So from peat, lignite, there is burial and compaction. So when we look at peat, we just should put an arrow which shows the peat gets buried, put some layers of sediment on top, therefore that'll influence the compaction, which releases the volatiles, leaving a thinner layer of lignite coal. Then from lignite to bituminous, there is even greater burial. So we show another arrow going down to another thin layer of coal, and above that you should dry in more layers of sediment, which is responsible for compacting the lignite coal to drive off more volatiles, so we end up with approximately 85% pure carbon. And this stage of coal we would call bituminous coal. And then from bituminous to anthracite, there is conditions favorable for metamorphism. So in the last diagram, we should show compressional forces, which cause the resulting sedimentary layers to be compressed, folding tight into folds. And because there are so many layers and the coal is buried deep down in the earth, it is also experiencing high heat. So the metamorphic conditions of high heat and compressional forces causing pressure would cause the bituminous coal to actually undergo metamorphism to form anthracite coal. And during all four stages of coal formation, volatiles such as water and gases are lost at all stages. In summary, let's look at the formation and the four stages that were involved in the formation of coal. The first stage of formation of coal was peat. Peat would be vegetative matter that grows in swamp areas. We should note at this point that peat is not a sedimentary rock nor a metamorphic rock, but peat is just plant material that has the potential to form into organic sedimentary rocks. The second stage in the formation of coal is lignite coal. Both lignite and bituminous coal are sedimentary rocks, and they form from the compaction of the plant material, the organic layer, when it was buried under several layers of sediment. Once this material gets buried under sediment, it drives off much of the volatiles, leaving high levels of carbon. Lignite coal would contain approximately 40% carbon, whereas bituminous coal would contain approximately 85% carbon. And both lignite and bituminous coal are examples of sedimentary rocks. Finally, our fourth stage in the formation of coal would be anthracite coal. Anthracite coal is a metamorphic rock that was exposed to high heat and pressure due to compressional forces. The previous bituminous coal layer would be exposed to extreme heat by deep burial and also by compressional forces, possibly from plate tectonics, which would result in the formation of a metamorphic rock that we call anthracite coal. So in review, peat would be plant material. It is not a rock. Lignite and bituminous coal are both sedimentary rocks, and anthracite would be a metamorphic rock. And this outlines your four stages in the formation of coal.